Okay, our last lesson for this unit is sort of takes a different stance from the Venn diagram stuff. It's on logic problems. In the curriculum, they require you to do a little bit of logic, and we're not just going to basically just do a million different questions. I just want to go through a few couples general type ones that they ask on a diploma. Typically, for every year's diploma, they always put about 3 logic type questions on, 2 or 3. Quite often they do magic square ones, sometimes they do some word logic problems, sometimes they do like little board game ones and so on. So we'll do a few today. We'll just look at maybe 3 or 4 different logic type questions. I'll kind of walk you through on how you would think them out, and most of them sort of work the same way. This first one that I've got here is a magic square, and the way the rules are, I don't have the rules on it, but they basically say put all numbers from 1 to 16, because it's a 4x4 grid, so there's 1 to 16. So every square has to be filled with one of those numbers, and every row and column has to have the same total, so they all add up to the same thing. So the question then is, what are the numbers, where would the numbers go that would work, so that you'd use each number once and they'd all add up to the same total. So this first one is it's not too tough of a one, but so the first step would be to figure out what that total is. So if you look at the way the grid is, we have this whole first row already filled in, so that makes it a little bit easy. And we add all those up. If we go 3 plus 16 plus 9 plus 6, add all those up on your calculator, we get a total of 34. So that's good to know. We know that their total then is 34, so we'll just write that up there so we don't forget. And now let's just use that along with our other logic to kind of help us figure out what the rest of it. So if you kind of look at this third row, or the second row from the top, we've got only one missing number, and we know that that has to equal 34, so that works pretty easy. We can just go 34 minus the 16 minus the 11 minus 2, and that'll give us that missing number. So 34 minus 16 is 18, minus 11 would be 7, minus 2 is 5. So we know that that one has to be a 5. Okay, so one down. So now the next trick is, which one should we do next? And this is about where some of these problems get challenging, is you have to remember or figure out how to get the next step. So we don't have any more rows or columns that have one missing number. So now you want to go to the next best thing. Which ones have 2 missing numbers? So let's look at this row. So we know that we have a 3 and an 8, so we know the other 2 numbers added to 3 and 8 have to equal 34. So if we go 34 minus 3 minus 8, that gives us 23. So what that means then is we know that the 2 unknown circles, the ones that we're looking for, those 2 add up to 23. Okay? You might think, well, how are we going to know that? But remember, each number we only go from 1 to 16 and nothing else. So let's kind of use that to help us figure out what it possibly could be. So what numbers could go in there that would add up to 23? So we already have 16 on the board, so 16 can't be used again. So let's use 15. If we had 15 plus what would equal 23, 15 and 8, right? 15 plus 8 would equal 23. But we can't use that because we already have an 8 already on the board. So 8 can't be right, so that means 15 can't be right either. So 15 and 8 are both wrong. So let's try the next one down. Let's try 14. So if we had 14 plus 3 plus 8 would equal the other number then would to give us 34 would have to be 9, right? We'd have 14 plus 9 would equal 23. Once again, we can't use 9 because 9 is already on the board. So that means if the 9 doesn't work, 14 can't work either. So that eliminates those ones. So now the next one then would have to be, let's try one less. So it'd be 13 and 10. So those look okay. We have no other 13 or 10s on the board. So let's, for now, before we move on, let's just see if there would be any other combination that would work. So let's try one less again. Let's do 12 and 11. But we have 11 and a 12 both on the board already, so those ones don't work. So we don't have to worry about the 12 and 11. And if we keep going, then it would switch to be 11 and 12 the other direction, so that we've already got that. So we're good. That's it. There is no other combination other than 13 and 10 that would work. So the only thing we got to be careful of now is, would the 13 go there and the 10 there, or should it be the other way around? Should it be 10 here and 13 there? So that's our only thing that we need to figure out. So it's got to be one or the other. So now what we want to do is do the same thing. Let's do kind of figure out what the two numbers would be for this row. We have another row that has only 2 digits. Okay, so we know that it's got to be either 13 or 10, and then the 2 and the 12. So 12 plus 2 is 14. So that means the other two numbers have to add up to 20, right? So it's got to be, if it was a 10, that means we'd have to have a 10 down here. If it was a 13, then it would have to be a 7. Okay? Which one does it have to be? Well, it can't be a 10. We can't have 10 on the board twice. So this one can't be a 10. It has to be the 13. So that means this one over here had to be the 10 instead of the 13. And then our last one, if that one was a 13, to make it add up to 34, this one had to be a 7. So we've got most of the board done. So all we got left is those 4 spots, and we can kind of do the exact same thing over again, but now you can see we even have less numbers to pick from. So sometimes it helps to sort of list the numbers that we've used or what we have left to use. So let's just make a list. We haven't used 1 yet. 2 is good, 3 is good, we need a 4, 5, 6, 7, 8, 9, 10 is good, 11, 12, 13 is good. All we have left is 14 and 15. So 1, 4, 14, and 15 are our 4 numbers. So we just have to figure out which ones work for that. And it's basically do it the same way. Pick another row or column that has 2 numbers done for you. So let's just to pick one, let's pick this row here. So we have 10 and 5, they have to add up to 34, so 10 and 5 is 15, 34 minus 15 is 19, so which 2 numbers add up to 19? And out of the ones that we have left, only 15 and 4 work. So this would have to be a 15 and a 4, or it could go the other way around. It could be 4 and 15 like that. Okay? And then let's do it the same way. Let's pick a row going the opposite direction and do the same math. So we have 9 and 7 is 16. It has to add up to 34. So 34 minus 16 is 18. So we know that the two digits have to add up to 18. Which are the ones that we have left that add up to 18? 14 and 4. So that means we have to have the 4. The 14 has to go there, or the 4, right? It could go the other way around. But we knew this one had to be 15 or 4. So 4 and 14, it has to go in that order. So we pretty much have the puzzle solved. So if this one had to be a 4, that means this one had to be 14. And then our 15 had to go there, so that means we have 1 left over there. And we're done. If you add up all of the different rows and columns, they'll all add up to 34. So you can see a little bit of a complicated question, but once you kind of solve a few of the obvious ones, the rest can be done fairly easily. Let's try one more, and a lot of you might have done lots of these kind of questions. So this is just a Sudoku puzzle. They typically don't give you complicated ones on a diploma that would take a long time. So they might give you a Sudoku, but it would be a smaller version that you could solve it fairly quick. But let's just do a regular one just to kind of play it. Those of you that have never played these, you might not quite understand how they work. So I'll go through this one with you. I'll go through kind of a sample one, and maybe we might not solve all of it, but I'll get you started. So the idea with Sudoku is you must put all the digits 1 to 9 in every row, in every column, and in every box. So let me just kind of show you what I mean. So this top row, we got 1, 2, 3, and 9 already listed. So that means there has to be a 4, a 5, a 6, 7, 8. So those digits have to be used, but they can go in any spot. And then the same thing works up and down. So let's just pick this row. We got this row here. We have to pick a 1 to 9 as well. So it means we need a 1, a 2, a 3, we got 4, 5. You can see here we got 2 5s, so that doesn't work. So obviously this one can't be a 5 because we already have a 5 there, so it'd have to be a 6 or something like that. And the same thing works within each 9 square box. So we got a 2, 4, 9s. That means we have to have a 1, 3, 5, 6, 7, and 8 would have to be the other numbers, but they could go in any spot as well. Okay. So the trick to these puzzles is how do you get them in the right spot so that they don't duplicate. So you can see even just the way I did this one, this can't be 1 and 3 because we already have a 1 and 3 there. Okay. This one can't be a 7 because we already got a 7 down there. And you can see the 1 is already there too. So we get lots of duplications just by doing guessing. So you can't guess, you have to sort of use some logic to help you figure out where they need to go. So I'm going to go through a couple of basic Sudoku sort of strategies that tend to work pretty good. And what I kind of tend to do them in sort of the same pattern over and over again just to help you out. So what I do is I go through the numbers in order and I try to fill in as many as we can. So let's start with the 1s. We know that there has to be a 1 in every row and every column, and they can't duplicate. So what I do is I find out where the 1s are on the board, and then I look sideways and up and down to see if there's any other 1s. So when we look sideways in these boxes, we have no other 1s. So that doesn't work. So we'll skip that one. But if we look up and down, you can see there's another 1 down here. So because there's a 1 at the top and a 1 at the bottom, that means there had to be, we can only have 1 in each row, so that means there has to be a 1 in, and there can only be 1 per box like this. So this box is missing a 1, we've got 1 already in this row, we've got 1 in this row, so that means our 1 then has to go in one of those 2 spots. And if we look sideways, we already have a 1 there, so that means that one can't work either. So just sort of by using the process of elimination, we got a 1 in each of those columns, and we got a 1, so like this one kind of takes out that column, that one takes out that column, this one takes out this row, so that means this one has to be a 1. Okay, you get the idea? And then I would just keep going with that. So now that we have a 1, let's just try it this way, we got a 1 in that row going across, so that can't be done. We got a 1 going across in this row. We got 1 in each of those boxes. That means the 1 could go in either of those spots. And if we look up and down, there are no other 1s, so that one isn't going to help us. We can't figure it out using the 1 going that way. And there's no other 1s on the board, so we're done with the 1s. So now I basically do the same thing over again with the 2s. I look for a 2. So 2 going across, there's none. 2 going down, there's none. So 2s aren't very good. So let's try the 3s. So you can see the 3 at the top, we got a 3 in this row. We got a 3 in this row, so that means there has to be a 3 in the bottom, and it has to be in this, either in this spot or this spot. And we have no other 3s, so we don't know which one it's going to be. So sometimes it's good to just sort of label them in pencil or something, so it could be in either of those 2, and we'll just leave it like that. But let's go sideways. We got a 3 here in this row. We got a 3 in this row, so that means the other 3 would have to go there or there. Okay, get the idea? And so that one's not going to work. So let's try the 4s. Just by looking quickly, 4s aren't going to work very good either. 5s, not so much. 9 is a good one. Let's jump to 9s. So you can see we got a 9 in this row. We got a 9 in this row. So in our bottom box, 9 would have to be either here or here. But we already have a 9 in this row here, so then that one can't happen, so it has to be in the middle. Okay, and then we do the same thing in other directions as well. So I'll stop there. So that's kind of one sort of strategy that I use often, is use the rows and columns to try to help you figure out missing ones. The other way to do this, let me get rid of these 3s because there could be one or the other. The other way is, once you have a box close to being filled, is you start looking to see where it could work. So let's just look at this bottom box. Right, we've got quite a few numbers in there, so that means we have to have a 1, 2, 3, 6 and 8. That's our leftover numbers. So then start looking at the other rows to see if those numbers could be eliminated. So 1 couldn't be here because there's already a 1 in this row, so that doesn't work. Okay, 1 can't be down here because there's 1 over here, so we sort of got rid of all 3 of those ones. So the 1 then has to be in one of these 2 spots. Okay, and we could do the same thing with a 2, right? We already have a 2 in this row, so it can't be in any of those, so that means the 2 would have to be there or there. But we already have a 2 in this row, so that means that 2 can't exist, so we know the 2 has to be down in this corner. Okay, so you can kind of work within one box and do sort of the same thing, look at all the other rows to see if you can eliminate any possibilities. And the other one I do is when you get lots of numbers in a row or a column, do the same sort of thing that we just did with the box. Okay, so if you look at this row here, or this column, we got lots of numbers filled in, so we know that there has to be a 1 left over, but there can't be in that spot because we've got a 1 there, right? So this one doesn't work. Could be there, that part's fine. Could be here or here, but we've got already a 1 in this square, so that means those ones don't work either. So this one would have to be gone, that one has to be gone because it's already in that row. So that means our 1 then has to be right there. And we can do the same thing for rows going across. So I'll stop there. It kind of gives you an idea how Sudokus work if you haven't played them before. This next one are kind of neat. I think they're called KenKens or something like that, where they're sort of like a Sudoku except they use some basic math things and sort of the same rules like magic squares. In this case, you have 5 rows and columns. So that means each box has to have a 1, 2, 3, 4, 5 in it. And instead of being where they got to just use them 1 each, they have to follow the math in the boxes. So if you look up in this top corner, it says these 2 boxes multiply to give you 10. So they have a 10 and a times. So that means what 2 numbers multiply to give you 10? They would have to be a 2 and a 5. Or it could go 5 and 2. That's really the only challenge with these, is you have to figure out which order they go in. Okay? So a 2 and a 5 or a 5 and a 2, one or the other in those boxes. And if we go to the one beside it, they have to subtract to give you 2. So we've already used 2 and 5, so that means out of the numbers that are left over, what would give us, subtract to give us 2? So that would be a 1 or a 3. So those have to be a 1 or a 3, and then that means our last box would have to be a 4. Okay, and it says what 2 numbers divide to give you 4. We know that one has to be a 4, so the only thing that would divide to give you 2, that one has to be a 2. So those 2 are set. We don't have to worry about those ones anymore. Okay, just because we got the 2, 5, 1, and 3, the 4 had to be there, and then the only thing that divides to give you 2 is 4 divided by 2. Okay, so that's how those ones work. We can do a little bit more just to sort of get the idea. And you can kind of pick and choose which boxes are the easiest. Let's kind of go down here. We got a 15 times, so that's pretty easy. It has to be a 3 and a 5, but it could go in the other way around, right? We could do a 5 and a 3 the other way, and then that means the bottom numbers then would be the other ones. So if it was a 5, that means we'd have a 3 and a 1 left over. Do those subtract to give you 2? Yes. If it was a 3, that means we'd have a 1 and a 5 left over, but they don't subtract to give you 2. So that helps. That helps us solve this one. So this has to be a 5 and 3 like this. Okay? But now down at the bottom, we don't know if it's going to be a 3 and a 1 or a 1 and a 3. So we've got to do both for now. So it could be a 1 and a 3 or a 3 and a 1. Okay? But now we can start combining some of these other rows. So we know that the 3 had to be here. So if we look up, we had a 1 or a 3 for that box. So if that one had to be a 3, that means this one up at the top has to be a 1. And then the 3 would go in the first box. Okay, so you can kind of see that as you start filling them in, it helps you figure out other rows. Alright, so we can kind of keep going. I'm not sure what would be my next option here. Maybe I would look at doing maybe these two boxes in here. Right, they have to subtract to give you a 1. So that means it'd have to be like 5 minus 4, right? Because we already used the 2. So we have 1, 3, 4, and 5. So you could do 5 and 4, or 3 and 4, but that doesn't work because we've already got a 3 here, so that can't be a 3, and we've already got a 3 in the other row. So that doesn't work. So 3 and 4 doesn't work. So it has to be 5 and 4. Yeah, there's no other option, but we don't know which order again. So it could go 5 or 4, or 5 or 4 in this box. Okay, and then same thing. We know that those have to be a 5 and 4. The other boxes then have to be a 1 and a 3. And they got to subtract to give you 2, so that works. 3 minus 1 is 2. And just keep on going like that. So the next row, we already got our 3 and a 5. We want two numbers to divide by 2, divide to give you 2. So they could be 4 and 2, or it could be 2 and 1. So that one, we're not sure which way to go. Let's go down to this one. We know these ones have to add up to 5. So they could be a 2 and a 3, or a 4 and a 1, or whatever. So I'll stop there, and if you're interested, you can kind of keep on trying to solve this. Like I said, any of these kind of puzzles on the diploma, typically they have a whole bunch already filled in, and they're just looking for a few leftover spots, but the logic is the same. One more quick one, and these ones are kind of fun to do. This one, they're called Shikokus. They're all Japanese type games. Japanese, I guess, love number puzzles or whatever. So what this one is it's kind of a fun one. What you want to do is you have to make a rectangle in the right number of squares that they show you. So on this one it says we got a 2. So that means we have to have a rectangle that has 2 squares in it, with the 2 being part of it. So that's one option. Or the only other way you could do this one is you could do 2 squares like that. Okay, so the idea is you want to be able to draw rectangles around the board that fills in all the squares and matches the right numbers that are drawn for you. And that's it. Typically my strategy for these ones is start with the big numbers. They tend to be the hardest to sort of figure out, and once you have the big ones, the rest sort of work out. So we'll start with the biggest on this one. It's a 6. So the only way we can get a rectangle of 6 would be to be 2 by 3 like this, or the other option would be 2 by 3 like that. And we're not sure which way it would go, so let's just skip that one for now. Let's go to the next biggest one. So the next biggest is a 5. Well, how can you draw a rectangle with 5 squares? You can't do it like 2 by 3 or whatever, so the only rectangle possible for 5 would be a 1 by 5. So it's got to be a long, skinny one like that. And in this case, we have to draw it up and down like that, because if we were to draw it sideways, right, we have a 5 and a 2 in the box, which you can't do. You can only have one number per box. So that one has to be like that. So we've got that one figured out. So then now let's go back to the 6. Now that we know it has to go like that, the 6 would have to be like that. So that one's good. Now we've got a couple of 4s. So well, you got to look to yourself and say, okay, well, if I have 4, I can't go 4 sideways, right, because there's already a box there, so that doesn't work. I can't go 4 up and down because there's a 2 there, so that doesn't work. So then our only possible for this 4 would be the 4 top squares like that. Okay? Same thing with the bottom 4. We got a 4, we can't go up or down because there's only 3 that way. Can't go sideways because there's already boxes, so then it also has to be a square, a 4 by 4 like that. And then that leaves the middle one to be 2, so that one would have to go there. And we're pretty much done the puzzle. The rest of it now is how do you get the 2 and 2. So you could draw a square like that and a square like that. This one actually has 2 possible solutions, so that's valid. You'd have the puzzle completed. Or we could have also done it 2 up and like that one. So either way, they're both good. So I'll stop there. I'll put on the Moodle page, I'll put some other puzzles just like these ones, but different numbers and stuff, and you can try a few of these on your own. And that's all for today.